Hello guys, welcome back to the channel. So today we are going to solve another Leetcode question for the day. Question number is 1457. It's a pseudo-palindromic paths in a binary tree. So we are given a binary tree where node values are digits from 1 to 9. So that's one constant, and then a path in a binary tree is said to be a pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. So as you all know, palindrome is something like, even if you look at the number, say 1 to 1, like if you look at from left side, it's 1 to 1, and then it's a similar from right side, it's 1 to 1. So that's the palindromic property. Now return the number of the pseudo palindromic paths going from root node to leaf nodes. Okay, so let's look at the first example. So we have this binary tree, and the solution and the explanation why it's 2 is why 2 is the output. So there are 3 paths going from root node to the leaf node, and the path is like 2 3 3. Okay, so that's not palindrome, but we can actually rearrange it to this 3 2 3. So that's one number, and then 2 1 1 is another one, because we can again rearrange them to 1 to 1. So that's again a palindrome. What we cannot do is 2 3 1, because all numbers are unique. We don't have a duplicate numbers, so we cannot really rearrange it or form any palindrome, right? So the number one intuition would be how we would be solving this. We all know about tree traversal. We can do any traversal. I like pre-order, so we'll be doing pre-order traversal here. But the idea is we will be looking at each branch, like each path, right? Because we will be considering 2 3 3, and then in the case of 2 1 1 we are again considering 2, right? So we are considering one number, one node again and again. So that's one thing to keep in mind. And then we need to keep track of the actual count, because the result needs to be the number of palindromic paths, right? So for returning the number of the pseudo palindromic paths, we will keep track of that value in our count variable. Okay, so this is count, and we will be returning count because that's output. Now we will need to traverse this tree, so we'll be using pre-order traversal, and we will have root in it, and then the path would be 0. Why I'm taking path as 0? Because let's go back into theory. Like if you look at any palindrome, what we can derive from it, any one character will be duplicates, like there will be duplicates. But again, you should also notice like there is at most one character that is an odd occurrence, and I'm telling it as an at most one, because we can have 1 2 2 1 as well, and that's a palindromic numbers as well. But we also want to take care of this case, right? So we need at most one character to be an odd occurrence. So to determine in real time if any number is a palindrome, we make use of bit operators, and one of the useful bit operator would be XOR, because it's the property for XOR that if there is 1 0, then its output is 1, and then if the both number, like both bits are 0 0 or 1 1, it's a 0. So that will help us here. So let me just code it here so we can move forward with it. So path is here, and now we are making use of count, which is an out of scope of this function, so we will declare it as non-local. Now if the node is present, so for the first iteration we'll be looking at node 2 here. So now we will make use of this path. As I already mentioned, we'll be using XOR for repeat operator. And how we will be using that, we will be using, and this is a trick, like you need to shift your digits to left, so that way, and with 1, right? So if you for instance you are making 2 into a left shift operator, and then you are making an XOR with 0, so 1 0, and that's again 1 because we are using XOR. We are shifting the node value to the left, and then also we are shifting our node value to the left, and then we are doing XOR. So let me just do this, but you get the idea, right? So now if node dot left is none and if node dot right is none, that means we are at the leaf node, right? So 2 3 3, we are at the last digit 3. So now we want to know if we are having path and path -1 equals to 0. That will just tell us that at most one digit has an odd occurrence, and with that we can have count increase to 1. And if it's not a leaf node, then we will just traverse with node dot left and then path, and the same thing will be for right. So I'll just copy paste it here, and there you have it. So let's run this and check. Let me check if everything is fine. If no, is there? Yep. Oops, I had wrong. We need an operator, yeah, not the AND keyword. So now it should work. So yeah, there you have it. So what we did here, just a recap, we are looking at the node values, the path of it, and then we are actually in real time we are noticing, or we are just computing the occurrence of each digit, and we at least want at most one digit that have an odd frequency, and this thing will help us in that. And once we have that, we will be doing, will be increasing count, and that's the result that we want. So let's just do submit and we should be fine. Yep, as you can see, it beats 100%. So make sure you like, comment or subscribe if you haven't really done already. See you in the next one.